This is circular motion example number 5, and this one deals with torque. We have Ned who's tightening a bolt in his car engine, so he's using this wrench, and as he uses the wrench he exerts a 12 Newton force on his wrench. So we say that the force is pushing this way, and it is 12 newtons, and that is our force. And it's exerted at a distance of 0.4 meters from the fulcrum. The fulcrum is where the center of the turning is occurring. So from here out to where his hand would be, which would be right here, we know that that is 0.40 meters, and that is the distance. Torque is really easily defined. Basically, we use the Greek letter for torque is looks like a T, and that's equal to force times distance. And if you remember, work is also equal to force times distance. So when you're confused about the work that needs to be done by a wrench or any other tool like that that's turning, you know you're doing work when you do it, and that should help you remember that you use the torque equation. At this point we can just put in our force, which is 12 newtons, and our distance, which is 0.4 meters. Multiply the two together and we end up with 4.8 newtons times a meter. Be careful, it's not Newton per meter, and it's not just a Newton. It needs to be a Newton times a meter. We will not use, for this one, we won't use joules. We're actually going to use a Newton times a meter.